welcome to CEC Gurukul lecture. In continuation with the series on Introduction to Sociological Research Methods, in today's lecture we are going to discuss on basic elements of scientific method, and there we are going to understand hypothesis. What is hypothesis? What is the role of hypothesis in social research? What are the types of hypothesis? How to frame valid hypothesis and the relevance of hypothesis in sociological research. In the previous research, we were talking about concepts, how concepts are central to understanding of the research methods because it is the most important element for doing research. And when we have concepts which are also facts, we then kind of understand the building of theory through the process of constructing valid hypothesis. So, let us try to understand the importance of hypothesis in social research. The meaning of facts in social research depends on a clear theoretical framework. Facts are not isolated. They represent relationship between well-defined concepts and must be organized by theory to gain explanatory power. Scientific method thus begins with the careful definition of concepts, after which the researcher must pose questions that generate new proposition. So, theory and hypothesis are two essential closely linked aspects of scientific knowledge acquisition. So, in the previous lecture, we have understood that to begin with any kind of research, we need to identify the important concepts. Now, once concepts have been identified and then we need to possess certain questions or propositions to have a more theoretical understanding, to link those concepts into a sound theoretical framework, and for that these propositions or tentative questions are basically the hypothesis. When we try to understand hypothesis and we know that theory and hypothesis are both important, then there is also a need to understand the relationship between theory and hypothesis. Theory gives order and direction to facts, revealing patterns and meaning. A hypothesis is a direct outgrowth of theory. It represents a specific testable deduction concerning relationship between concepts or variables that the theory suggests should be true. So, through the process of research, the hypothesis is either proved false or true, and therefore, the hypothesis is basically a kind of a deduction, and it creates a relationship between the ways in which the concepts and theories are connected. All facts are gathered and organized into a pattern. They support or challenge elements of theory. When existing facts are ordered by theory, they allow logical analysis and the deduction of further relationships, that is hypothesis. A hypothesis is thus a proposition stating what the researcher expects to find. If verified, it is incorporated into theory, expanding and refining it. The distinction is functional rather than absolute. Theory is an elaborate general framework, while a hypothesis is a specific testable supposition derived from the theory. So, in order to either validate the theory, the proposition the hypothesis is important. In practice, a theory may be viewed as a complex set of interrelated hypotheses about a wider range of facts, with each hypothesis subject to empirical testing and possible integration into the broader theory if verified. Now, if we look into the connection between concepts, theory, hypothesis, fact, it can be concluded that there is a cycle of knowledge. That means, all the connection between facts, concepts, hypothesis, theory is kind of in a form of a continuous cycle. The theory is built upon fact. new relationship logically deduced from the theory. These deduced relationships are formulated as hypotheses. The hypothesis is tested through research gathering new fact. So, you see it goes back to fact, begins with the facts and goes back to fact. So, that therefore, it is a cycle. If the hypothesis is verified, it becomes a new fact that is incorporated into a future theoretical construction, refining or expanding the original theory. Now, we have understood that there is a connection between theory and hypothesis. So, a theory is basically a broad elaborate hypothesis dealing with many types of fact, while a hypothesis is a testable prediction derived from the theory. The two are practically inseparable, acting as the mechanism by which science adds to its knowledge base. A hypothesis is fundamentally a forward-looking proposition. It is an idea or assumption that can be empirically tested for its validity, regardless of whether it aligns with a common sense or established belief. So, when we know what is an hypothesis, we have understood the relationship between theory and hypothesis. So, what is the why do we try to have a hypothesis? Therefore, it has some functions or role. Its essential role is to invite empirical testing, that is, encourage scientific inquiry by posing a specific answerable question. This reflects the principle of organized skepticism in science, which demands empirical verification before accepting any claim. A hypothesis serves as a bridge between theory and empirical observation, translating theoretical ideas into statements that can be tested through data collection. The outcome of testing a hypothesis, whether confirmed or refuted, provides an answer, further scientific understanding, and often prompting new questions. This process embodies the self-correcting skeptical ethos of science, which requires that no statement be accepted without testing against observable facts. Robust scientific theories are valuable because they allow the formulation of new hypothesis. So, we begin with concepts and then we kind of arrive at certain testable, tentative questions. On the basis of those questions being answered and the theory being further strengthened, it leads to the construction of new concepts and facts and again into the formulation of new hypotheses. Each hypothesis that is tested and either supported or rejected feeds back into the development of theory, refining or challenging existing framework and paving the way for additional hypotheses and research. This iterative process, though seemingly straightforward, is complex in practice. Formulating meaningful testable hypotheses is one of the most intellectually demanding steps in the scientific method. Regardless of the outcome, the test results contribute to existing theory and enable the formulation of still other hypotheses, driving the continuous cycle of scientific inquiry. Now, where it's not so simple that you kind of formulate a hypothesis, there are certain difficulties in constructions or formulations of hypothesis, and therefore, when we know that it is significant, it has an important role in social research, it is also at the same time important to understand the difficulty of formulation. So, the formulation of a useful hypothesis is one of the most difficult steps in scientific method. This difficulty stems from the requirement that a hypothesis must be, number one, derived logically from a theory. Number two, specific enough to be empirically measurable. And number three, relevant to central non-trivial factors. Now, why do these difficulties arise? The difficulty arises at three instances. Number one, when there is a lack of a clear theoretical framework. So, we start off doing a research, we have a statement problem, but we have not are not aware of the theoretical framework of the research. In that case, developing a hypothesis would be difficult. Number two, inability to use theory logically. Now, we know the theory, we have a theoretical framework, but we are unable to connect the theory to the research problem statement, and in that case also a hypothesis would be difficult to formulate. Number three, insufficient knowledge of research techniques. Now, we need to test these hypotheses, and therefore, you should have a sound research technique to kind of validate the hypothesis, to test the hypothesis. If that is not present, then again the difficulty arises. Now, we know that hypothesis is important. So, how do we understand what is a good hypothesis or what makes a good hypothesis? Simply selecting a topic area, for example, juvenile delinquency, courtship behavior, anything for that matter, does not constitute a hypothesis, as it does not pose a specific question or establish an explicit relationship to test. Proposing replication of earlier research, expecting similar outcome, is useful for confirmation, but it rarely advances new theoretical knowledge. It primarily checks reliability. Studying empirical regularities predicts some type of pattern but remains vague regarding the nature or direction of relationship, resulting in hypothesis of low abstraction. Therefore, we need to be very careful and formulate strong hypotheses. How do we do that? So, we begin with a broad theory and deduce a specific testable relationship between two or more clearly defined factors or concepts. For example, a well formulated hypothesis might predict higher parental supervision is associated with low rate of juvenile delinquency among urban adolescents. Now, this is explicitly stating a testable relationship between parenting and juvenile delinquency. So, the variables or the concepts that needs to be measured are clearly defined. Now, developing a precise and testable hypothesis is a skill that improves with experience and theoretical engagement and constitutes one of the greatest intellectual challenges in scientific research. So, now that we have understood what a hypothesis, the relation between theory and hypothesis, what a good hypothesis, how to construct a good hypothesis is, here Goody and Hatt gives us the typology of hypothesis. Now, this classification of hypothesis is based on the level of abstraction. Now, abstractions means that we are only picking out the important, focusing on some of the important, and there are a lot of elements which can be hidden. So, the higher the level of this three types is in the form of a descending. The first has a higher level of abstraction and then it goes down to the second and third. The first type of hypothesis is empirical uniformity hypothesis, which deals with the existence of empirical uniformities, which often examine common sense propositions scientifically. These hypotheses focus on observable pattern or regularities in social phenomena that seem intuitive or widely recognized in everyday life. For example, studying the distribution of business establishment in a city, the ethnic composition of workers in an industry. Some empirical uniformity studies describe behavior pattern within a specific group, such as conformity and non-conformity among college freshmen participating in initiation rite or fraternity pledging. Such research provide descriptive statistics, tabulation, graph or map that express degrees of uniformity or variation in social behavior. It is sometimes argued that these investigations simply add up facts rather than testing hypotheses, implying limited scientific value. However, the line between description and hypothesis testing can be blurred. Many of these studies do test common sense ideas as hypotheses, putting them into precise, testable forms. Another criticism is that these hypotheses may reflect what everybody already knows, making them seem redundant. Yet, social science addressed this by defining concepts precisely and integrating findings into theoretical framework, improving rigor and clarity. Additionally, common sense beliefs may be incorrect. Empirically testing them can confirm, refine, or refute such assumptions, thereby advancing scientific knowledge. Thus, this type of hypothesis plays an important role in establishing foundational empirical knowledge in sociology by rigorously testing and clarifying common sense observation. In sociology, dealing with common sense knowledge and folk belief requires careful transformation into scientifically valid knowledge, because if it's common sense, that it cannot be taken as scientific. So, sociology needs to kind of convert this common sense folk knowledge into scientific knowledge, and that is kind of one of the way in which a hypothesis helps social research to do the task. So, the task for transforming folk knowledge into scientific knowledge is especially true given sociology's relative early stage of development, where everyday understanding of social relations are often mixed with glitches, moral judgment, and vague concepts. To transform common sense belief into testable, useful knowledge, three tasks must be performed. Number one, removal of value judgment. Statements that merely express sentiment or moral overtone, example, bad children are born that way, must be stripped of these subjective biases. The second way of transforming the folk knowledge into scientific knowledge is clarification of term. Concepts in common sense generalization are often vague. It can have multiple or subjective meaning. But when it is transformed into scientific knowledge, it will have clarity. So, each concept will have one specific meaning in that particular study or context. For example, what constitutes bad children or self-indulged lives? Now, bad children can be defined in different way, but when we are doing a research, and there the definition of bad children would be very specific to the research. So, they must be put into carefully defined precise term. The third way of transforming folk knowledge into scientific knowledge is application of validity test. The resulting clarified proposition must be subject to rigorous empirical checking of fact. Science, including sociology, finds common sense knowledge fruitful for study even when it is wrong. So, how do we test common sense? So, many past belief, for example, the sun revolving around the earth, horse hairs turning to worms, asafoetida preventing cold, were widely accepted but disproved by patient empirical checking. The primary justification for testing common sense is that it is often incorrect. The monumental sociological work, The American Soldier, was criticized for elaborating the obvious by testing hypotheses that critics felt were already known or clear from common experience. However, the research proved the value of empirical testing by showing that these common sense assumptions were in fact incorrect. People often believe a result is common sense only after the investigation is complete because they can find experience to fit the outcome. If the result has been different, they would have found other contrary experience to rationalize that different result. This retrospective bias highlights why empirical testing is essential. It provides an answer that could not have been reliably predicted beforehand. The second type of hypothesis is hypothesis of complex ideal type. These hypotheses move beyond simple observation to explain relationship between multiple observed uniformity. So, the level of abstraction here is less than the first type of hypothesis. Now, hypothesis of complex ideal types aim at testing the existence of logically derived relationship between multiple empirical uniformity. Instead of simply stating that a uniformity exists, like the first type of hypothesis does, these hypotheses integrate several uniformities into a single complex theoretical construct. The core of this hypothesis is the ideal type or construct. An ideal type is purposeful distortion of empirical exactness and a logical construction that is removed from perfect empirical reality. Its function is to create tools and problems for further research in otherwise highly complex areas of investigation. These hypotheses are considered verified under certain conditions of maximum opportunity. Instances of ideal type occur even if not every single case perfectly fits the model. Example of ideal type hypothesis: empirical uniformities. Early human ecology observed regular pattern in the distribution of various phenomena within cities: land values, industrial concentration, business type, ethnic group, mental disorder, etc. Hypothesis of ideal type is used by Ernest W. Burgess statement of concentric growth circle. Example: the city expands outward from a central business district in a series of rings. This remains a hypothesis for some, as it fits to actual city growth is debated and subject to more crucial testing. The third type of hypothesis is hypothesis of analytical variable. These hypotheses represent the most abstract, sophisticated and flexible mode of hypothesis formulation. They move beyond simple observable empirical uniformity and complex construct, that is ideal type, to focus on the dynamic relationship between measurable property. To formulate a relationship between change in one's property, which is a variable, and change in another property, also a variable, requires abstracting specific qualities from real world context and holding effects of certain variables constant or controlled to measure isolated relationship between others. To take an example from sociology, the study of human fertility might show empirical regularities by wealth, region, size of community and region. If this were then raised to the level of ideal type formulation, one result might be the hypothesis that there are two high fertility population segments in the United States. One is the southern rural Protestant and the other is northern urban Catholic. At a still higher level of abstraction, the qualities of region, size of community and religion might be abstracted and controlled, that is, the effects on fertility held constant. This would allow a better measurement of the relationship between the variables of wealth and fertility. This level of hypothesizing is not only more abstract than the other, it is also the most sophisticated and the most flexible mode of formulation. At this level, the number of variables can be abstracted and studied is limited only by theory. So, we have three types of hypothesis: empirical uniformity, focus on simple differences, fertility higher in the south. Second is ideal type, focus on specific coincidence of observation integrated into a complex type, for example, low income, southern rural Protestant, high fertility segment. And third is analytical variable, which is type 3, focus on how continuous change in one variable affect change in another, that is wealth affects fertility. So, we have come to a good understanding of what is hypothesis, types of hypothesis, and to get a good understanding, the reference for this lecture is Goody, W.E. and P.K. Hatt, book published in 1952. The title of the book is Method in Social Research, and this hypothesis is chapter 6 of the book. With this, I come to an end of this lecture. Thank you.